Excuse me, guys. Alright, today we're continuing on with section 2.2 in Algebra 2. We're going to be talking about quadratics still. This entire chapter is quadratics. Today we're talking about standard form of a quadratic equation and x-intercept form. Standard form is y equals ax squared plus bx plus c. Remember, a is still the multiplier. It still determines whether the parabola opens upward or downward. Remember also that the axis of symmetry always goes through the vertex. That will become important. C in that equation that I just erased is not part of the vertex. C is not part of the vertex, but it is going to be something else. So my example number first. I have y equals 3x squared. I want a graph. I'm not going to use graph paper, but you always will. Y equals 3x squared minus 6x plus 1. You will always show me all of your work. You will always do it in pencil. You will not do it on your laptop or on your iPad or anything else. Alright, the formula to find the axis of symmetry is x equals a negative b over 2a. That is the formula to find that axis of symmetry. Since I told you that the axis of symmetry always goes to the vertex, once I find that, that is always going to be the x-coordinate of my vertex. So in this problem, I have x is equal to, my formula says a negative, and then my equation has a negative b. So it's a negative 6 all over 2 times my a, which is 3. Just using these forms, this is a, that's b, and that's c. Remember, c is not part of the vertex. So this is equal to a positive 6 over 6, which is equal to a positive 1. So my axis of symmetry is a line, so it's an equation. X equals 1. You cannot say just 1. It's x equals 1. Once I know x equals 1, I can go to my vertex and say x equals 1. Now then, to find my y-coordinate of the vertex, I need to take that 1 and plug it in everywhere I see an x. So y is equal to, I'm trying to find y, so y equals 3. Whenever you substitute, always put the number you're substituting in parentheses. That will help you, especially when you have negatives. 6 times 1 plus 1. Which is equal to a negative 3 plus 4. That is equal to a negative 2. So my vertex is at 1 comma negative 2. Alright, so now then, all I have to do is come down here and come over here. And that's it. So it's 1 and negative 2. Down there is my vertex. I do have a multiplier. Remember my parent graph always has the point. Remember, the parent graph is y equals x squared. You don't say it's quadratic whenever they ask you what the parent graph is. The parent graph, the equation is y equals x squared. Okay, so my parent graph is always 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, so on and so forth. This time I have a multiplier. It's positive, it's going to open upwards. So, from here, when x is 0, y is 0. When x is 1, y is usually 1, but now it is negative 1. I'm sorry, I did this wrong. It is a positive 1, negative 2. I need to come up this way and negative 2. I went on the left-hand side, that was positive, and you go to the right-hand side. Okay, so when x is 1, y is going to be a negative 2. Okay, now my points. When x is 0, y is 0. When x is 1, y is usually 1, but now it's 1 times 3, so it's 1, 2, 3, right up there. When x is 2, 1, 2, y is usually 4, but now it's 4 times 3, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right up there. The axis of symmetry goes through the vertex. So I need to draw my axis of symmetry. You have to draw it, and you have to label it. My axis of symmetry is x equals 1. Alright, so now I have my sister points on the other side of my axis of symmetry. This was 1 away from my axis of symmetry, so over here I go 1 away, and it's right there. Over here, this guy was 2 away, so I go 2 away over here. And now I can draw my parabola, which is always a rounded curve. It's a smooth curve. It is not a V shape. And yeah, that's ugly. That's why we don't use that. That's why we always use graph paper. Okay, couple of things right here. I told you that has a special meaning to it. It is not my y coordinate. That's negative 2. That's obviously not a 1. But what that C does represent is my y-intercept. So C is equal to the y-intercept. So notice right here, my y-intercept is right there at 1. That's a quick check to let you know if you're going on the right track. Alright, another thing to look at. Whenever my parabola is opening upwards, this vertex is my lowest point. I'm coming down from here, and then I hit the lowest, and I go back up. Whenever it opens upward, this guy is the negative. So notice right there, it's at the y equals a negative 2. So everything, let's do it this way, my domain is always the x values. Since this guy is opening upward and there's an arrow, it keeps getting higher, it keeps getting wider. Forever and ever in the x and the negative x. So my domain, I use this r for all real numbers, from the negative infinity to the positive infinity. My range, however, only starts at a negative 2. It does not have a negative 5, negative 10, nothing else. It starts at negative 2, then it goes on forever. So my range is all the values of y that are greater than or equal to a negative 2. And this point right here is a minimum point, because that's the lowest that it will get. That's the minimum point. Alright, so take a look at that example. I hope you're watching these videos. Obviously, if you're watching it, then you're watching the videos. If you're not, you did not hear my sentence just now, so I'll shut up because that was silly.